Alright, when we are working with radicals and exponents, it's actually really simple sometimes to solve them if we can convert forms. Sometimes it's just good to know how to convert forms between the two. That way you can look at the problem in a different way and try and make some more sense of it. So what I have here is I have a couple problems that are listed as radicals. We've got a couple other problems that are listed as exponents. We're just going to see the relation between the two. We'll flip back and forth kind of between the two forms, and I'll show you how we can simplify them, if we can simplify them, when they're in their radical form. So we have the square root of 10 being raised to the third power. Anytime we have a square root sign and we don't have a number in our pivot point here, that's hard to see, and we don't have a number in our pivot point here, I'm going to rewrite it. So I've got 10 to the third power. We need to generalize that that's going to be a 2 since it is a square root. So then when we write this, our base stays the same. So my 10 stays the same. My number that I'm raising it to is going to become the numerator. Then my pivot number is going to become the denominator. So same thing for the one below it. My 2 is my base, so I'm going to write 2. My 5 will be my numerator. My 4 will be my denominator. And then for 2, the third root of 2, I will put 2 as my base. There's a 1. I can assume it's to the first power, since it's not there, it's assumed. And then my pivot will be my 3, so it'll be to the 1/3 power. So when I rewrite them, I can rewrite them. Looks just like this. When I go the other way, my 7 is my base. My pivot number is a 2. My radical is a 1. I could just leave this one as square root of 7. For my next one, my 2 is here. My pivot number is at 3, so I'm taking the third root of 2 to the 5th power. You can either write it on the inside or the outside of the radical. And the last one would be 6. I've got, it's a square root being raised to the 3rd power. And then if we want to simplify these a little bit more, we'll look at the last one here. I have 6 to the 3rd power, and we're taking the square root of it. If I have 6 to the 3rd power, that really means I have 6 times 6 times 6. Now, the thing about this square root here, or this 2 in my pivot point, it just tells me that I'm looking for any two numbers that are same that I can pull out together. So really, when I look, I can see I have a pair of 6's here that I can pull outside of my radical. And then my 6 breaks down to 3 and 2, but since there's no pairs, my 6 is going to have to stay inside the radical. So my answer here, my simplified form, will be a 6. And it can look just like that. Another example, just so we can go through it real quick. Let's say I had, we'll say 5 to the 5/3. Actually, I don't want to call that 5. Let's call that 9 to the 5/3. So if I rewrite it, I would have 9 to the 5th in here. And I'd have a 3 inside here. So I can rewrite this as 9 times 9 times 9 times 9 times 9. And I can see I'm looking for pairs of 3. I have 3 9's here. The 9's I have remaining I can break down more. So 9 is 3 and 3. 9 is 3 and 3. So I can see I have 3 more pairs here. So now when I go to rewrite this as a radical, I'm going to take my 9, I'm going to take my factor of 3, and I'm going to write those outside of the radical. On the inside of the radical, I'm going to put whatever was remaining, and that one was remaining. So I could write this as 9 times 3, which is 27, and the third root of 3.